All right, here's kind of a fun one to think about. I have the composite function of the cosine of the inverse tangent of 5/12. Whoa, whoa, wait a minute. Why are we changing cosines and tangents? Why can't they just be all cosines or all sines? Well, because we can. So let's kind of figure out what this means and maybe start to unpack of what's going on and maybe start to figure out how we can remember some of the other tools that we've used along the way to kind of help solve the problem. Again, many ways to solve it. One that we're going to look at is, so let's deal with this inside beast first. It's a beast. We're looking at the inverse tangent of 5/12. And what that's asking us is whose angle produces, or which tangent angle produces a 5/12. Um, and we remember we're looking in our domain. So let's because our tangent functions were defined from what was it, negative pi halves to pi halves in its regular domain, and then its inverse function was all real numbers. And so let's look at this. So let's draw a triangle. And again, what we're looking at is we have an angle. And I want to know whose angle right there produces 5/12. And if I remember what those things were, the tangent was this leg over that leg. It was the opposite over the adjacent. So I have 5/12. So this is what it's expressing. Whose angle, we don't know, produces a 5/12. That's what the inverse tangent or the inverse function is asking us. So if I put that in there and I have that idea is basically which angle that equals, this might be the wrong way of saying it. Yeah, we'll just say that for a second. This inside is the inverse tangent of 5/12. Let's find out the rest information that I have here. If this is a 5/12 right triangle, and if I remembered from before that its hypotenuse is, we want to find its hypotenuse, which was 13. So I have a 5/12, 13 standard right triangle. And this is a triangle that I'm dealing with. This is the information I got from understanding what the inverse tangent is. Now let's look at this angle. Now I'm asking, what's the cosine of this particular angle? What's the cosine of the angle? And the cosine of the angle was adjacent over hypotenuse, 12/13. So the cosine of the inverse tangent of 5/12, the cosine of this particular angle that helps set this up equals 12/13. So therefore I can say the composite function of that original beast equals 12/13.